It's a new year. And I've been really busy and I haven't really recorded any board repair videos for a while. Hope everyone had a nice new year. We have an A2485. This is brought in from another shop. They replaced the top case and then I want to turn on. Look at this a little bit. I don't really, well, nothing really looked damaged. They had sent me pictures and they saw a little bit of liquid damage in one area, which was right here. As we can see, we have some remnants of liquid damage. What this device does, well, here, let's build our Enigma here. We plug in a charger. You can see in the lower left here, we get 5 volts, spikes up to like 0.3 amps, then just kind of hovers around, 0.05, like nothing. This looks very similar to something that maybe just has like, well, it's pulsing, so, but still, like the, average wattage that we're getting is something similar we might see to like a, PP bus AON or 3.3 AON, 3V8 AON, some early stage, always on rail, short circuiting, so power stopping really, really quickly. These lines here are for the SSD. The line's fine, and the part here that's corroded, I think they just cleaned it with a brush, and this part fell off. It doesn't matter, basically. So the part that we have falling, I'm kind of upside down here, but what I believe it's this guy right here. 2v5 NAND is at maybe, I think it was like 300 ohms or so. In any case, the line's fine. That's not our problem. The liquid damage is a red herring. Basically, this doesn't really matter. We'll still just kind of probably just replace these two caps. Why not? In for a penny, in for a pound. The capacitance of these two items here relative to the capacitance of the line in total is minuscule and doesn't really matter. These could both not be here. We don't really care about them. We'll still swap them out anyway. I just don't want that. This cap, for example, that's corroded right here might become a problem later, short out, and maybe damage the storage. So I want to get those swapped out in the area cleaned up. Let me go back to the because what I did notice, just kind of looking at the board, there was really no other signs of liquid damage. The board's actually quite clean. I noticed this sort of thing, and that might not even, you can actually see that very well on the main cam. What's going on here? It almost looks like flux or rework or something like that. It is, I believe, our charging IC, and there's kind of just some schmutz on it. It looks almost like rework was done. The shop didn't do this. So I'm thinking this chip got spicy. And like, many charge chips on MacBooks before, this is generally just killed by an aftermarket charger or something like that. I guess I'm kind of dubiously speculating at the moment, but these chips on MacBooks, not specifically just this A2485, but really all of them, they're sensitive. The charger and this chip, or generally what you see now is the USB-C controllers, because they're also kind of, communicating quite a bit with the USB-C chargers. In any case, the charger gets into an argument with the MacBook, and the charger is going to win 100% of the time. Because, we don't like fuses on Apple machines. We did the chips to fuse. And I did see this behaving in a bit of a silly way on the thermal imager. I'll show you what that looks like. Generally, really low wattage sort of behavior. You're not going to see useful data on here. Because I was thinking we had like a PP bus, 3V3, 3V8, 12V6, short circuit. We don't. None of those lines are short. We have voltage present on all of them. It's a little bit low, but nothing crazy. So then, okay, let's bust out the thermal camera then, because we don't have just like a main, short on one of these AON lines. So maybe some chips misbehaving was my thought. And We can see this guy's getting a little bit warm around the edges. It seems maybe, you know, very, very slight. We can see it kind of spike up randomly a few degrees, and then, you know, it'll go back down kind of as the thing cycles. So that's probably not supposed to do that. And there's some goo going out from the chip, so I'm thinking that it's probably bad. I think I can just pull this off of an A2338 board. This looks similar to our friend, the TPS 62820. Little buck controller. So we'll use the part search function on Flex Board View. And I'm going to search for this right here, this 35353S02432. And usually all these other settings as is, basically. See, we see it on our, 14-inch Pro boards or 16-inch Pro boards. Let's see. Got a lot of files to look through. So it looks like it's only on 16-inch M1 is the schematic I have, a M2 MacBook Air, and an M2 Max 14-inch A2779. I have a donor for this. It looks like we're doing the same things here. Let's see. So we want U5200. I'm going to go grab a donor. We're going to pull that chip off and reball it and get that on here. And then we'll see what happens. Okay. We have our donor. I like to remove the bad boy first. Let's get that off. Okay. Look at our, now I have a 3000 series NVIDIA card, and I'm actually very pleased with the noise canceling in OBS now. I'm hoping. Right now I have my fume extractor on max, so we'll see if it's actually getting out all that noise, but it seems to be working well thus far. Just listening to myself talk for a little bit from the last clip. I wanted to make sure the audio sounded okay. I have my hot air at 430. We're at 120 airflow. I'm going to remove this chip. Different. Now, where are my good tweezers? Go ahead and prep area. Throw the bad chip in the trash. I don't mix it up with the good one. Put some leaded solder. My Hako micro pencil with knife edge. Link in description. Just want to get leaded solder on these joints. Okay. Now we can wick. We add the leaded solder to the pads as to lower the average melting temperature of the alloy that is on there. Put more flux. Bring it around town. That looks pretty good. That's okay. All right. I'm going to get out. I seem to just use this A7 iPhone CPU stencil for everything. Should work for this, I think. Get my stencil. Okay, let's pull our chip off of here. And then we will roll it. And then we'll dig around for, well, then we'll see if this works. Then we'll dig around for replacement capacitors. For those ones near that 2V5 that were no bueno. This is a little tiny Mac Air board, so as you can see, it heats up much easier. These Mac Air boards, honestly, well, there's not a lot of components, but when you need to remove stuff, they're easier to remove. Kind of same principle here. We want to get all this leaded solder off of the chip. So get a little bit of flux on there, and get the micro pencil, some leaded solder, and get off all the poo-poo solder that is on there from the factory. We want nice, robust solder alloy on the work we're doing so that I don't have to do things twice. Okay, that's good. You can get a Q-tip, clean it off, get some solder paste if I can find it. Oh gosh, where do I have that? There we go. Moving stuff around. We already have some dried up paste on my scalpel blade, so we'll just do that. That's fine. Fine. Get our stencil in position here. Actually, move this board out of the way for a second. And we got some solder paste, which has already been dried out with a paper towel. And we're going to smoosh. I'm holding down the stencil with my fingers while I'm doing this so it doesn't shift. I always like to, with solder paste, just come at it from at least 2 angles as to get a more even spread. When I have gloves on, so I'm just going to go like this, kind of get any extra residue off. I'm going to get in there with my tweezers, kind of hold it in the center. I'm going to go to 345, and we're going to kind of slowly heat around the area a little bit. Good. chip out of the stencil. There we go. And while this is out of the stencil, I'm just going to grab it again with my tweezers. There's already kind of some flux on there. And we just want to kind of remelt these so they're nice and even. Good. Pump it in your balls. Or just, it's always good to check. Just check your balls. I'll make sure they're even. Okay, let's get this chip on our board. See what happens. A little bit of kind of solder paste residue on my table. I'm going to get out of the way. Okay. Go back to our A2485 schematic. Our pin 1 is going to be in our upper left. I like to set my pin 1 to pink. Then it sticks out. You can change all the colors in Flex board view. It's very fun. And just flipping it over is the hardest part. Looks like our dot's there. I want a position like this. Yeah, I reckon there's honestly enough flux residue there already. And what I'll do so I don't have to get my tweezers all in there is I'm going to sneak up on the thing. So I'm pretty far back with my heat. I want the board to kind of gradually heat up. We sneak up on the chip with the high airflow so we don't, shoot it off the board, basically. I'm getting, a millimeter closer each circle. The first group. So we want to see it kind of straightens itself out. Give it a little bit more heat just to make sure all those balls under the chip melt. And then we're going to not touch this for a second. What you don't want to do is immediately go in there with a Q-tip and smush your chip and ruin the reball you just did. We'll see if this works or there's something else going on. The board's nice and warm right now, so that's always a good time to clean it. I guess I wait, a few seconds there. You can get a lot of that flux residue off just like this. That residue makes me think that this was like refurbished or something, though the stuff that was on there earlier. The shop this isn't from wouldn't have done that, but probably that chip was replaced at some point before. Or it's just slime of some kind, and this is just not the problem. We'll see. Soon enough. Okay. Port's still pretty warm there, so while that's cooling down, let's find replacement capacitors. Okay. Probably just pull some off of this M2 I have here. The values on this, like 15 picofarads or something like that. So 210UF 0402 6.3. We could use the part search function. I assume I just am going to have some of these near the storage somewhere. Those 0402s. Close. Perhaps. There we go. All right, so we can pull this guy. Where am I actually on this board? here. Oh, again, let's go ahead and prep the area on our donor first. I'd like to have this angled in a way where I'm not pointing hot air at the mans. We found our guys, actually. Let's just see if this turns on now. We start replacing more stuff. Okay. All right, we got our USB-C port in. I'm going to plug in a charger. And more or less the same exact behavior. Red herring, red herring, red herring. Where art thou? Let's go back to basics and just see where our power stops. Okay. Go back here. All right, so not our problem then. All right, so we got 12.27 volts on PP bus AON. .33 AON. Measure that third pin over here. 3.3 volts. For movie 8 AON. Oh, let's measure that. Up here. .6 volts, so a little bit low. V8 perchance. We have some AON line. It's not behaving. Pretty low voltage on that, like 500 millivolts. See if we have a short. And we do have, 20 ohms here. This line is low voltage. That very well might be normal, and I'm not entirely sure. Even I am not sure about things sometimes. Where I don't remember actually where I was last there with the 16-inch board. We replaced this charging IC, same issue. If we're thinking about, power sequence on these M1s, kind of, order of operations, if we were going through our AON lines, we didn't have any shorts on kind of our usual suspects, which are just PP bus AON, PP3V8 AON, or VDD main 3V3, etc. And then at 1V8 AON, we had like 0.5 volts, so pretty low. And we were getting about 20 ohms on it. And I wasn't actually 100% sure if 20 ohms is normal or not. So I grabbed a 14-inch I have in here for different issues. This one just has a screen problem, but is working otherwise. And we can check this line here and see what we're getting. Getting about 43,000 ohms. So we can be pretty confident that 1V8ON is not supposed to be 20. So this is always useful to have, donor boards just to reference measurements. I know in some of the schematics on Flex Board View now you can actually get, known good diode mode measurements just inbuilt in the. So what we're measuring right here. This is 1V8AON on a M2 14-inch. So we'll go back to our 16-inch and same sort of thing. We got a basically G3 hot, always on rail that's short. We're gonna send power into it and see what happens here. Get this ready. All right, I started tweaking a little bit with this MacBook, and essentially, what we see. I could swear to God I was getting a low voltage on 1V8 AON. In any case, though, I'm getting 1.2 volts on 3V or on PP1V8 AON. Just kind of order operations here. PP bus, we have 12.28. We have 3.79 on 3V8. We have 3V3 on 3V3. 1.2 on 1V8 AON. And then we have nothing on any of our S2 rails. I replaced this, this silly chip on the back of the board. Pulled it off of an M2. It's the same chip number. And I don't see the behavior I saw on the thermal camera on this that I saw with the other chip. But I see essentially the exact same power behavior. Right now this USB-C is actually plugged into a different machine. I'm going to unplug it. It's probably confusing. This isn't plugged in right now. So I measure around. I didn't really find anything weird. For whatever reason, I'm getting like 60 ohms on PP1V8 AON. I measured, for example, on another A2485 device I have in here for there's like a screen repair, and it's at about 60,000 ohms on that line. And this line here is at about 60 ohms. But we inject voltage into 1V8 and I get no current draw. It's not short. For whatever reason, this board has low resistance on that line. But what I do see when I plug in the USB-C is that if you'll see here in the lower left, I'm plugging in this guy here, all right? We plug it in, and for a split second, the amperage is at like 0.3. So I noticed that PP5ES2 is pulsing ever so slightly up to like 7 millivolts, which is kind of a nothing, but that we're getting pulsing. This device isn't in DFU mode. It doesn't detect an Apple configurator. Even if you try to force DFU, it doesn't show up in DFU by soldering, wires on the points over here. So I'm like, God, I've been scouting around with the thermal camera, looking at all this stuff, and then I remember, there's a little bit of liquid damage on this board right over here. I removed those two caps that looked ugly, and I did also try just reflowing this chip because I also noticed I didn't have any SSD voltages, but I thought maybe that's just because we're not getting past S2. And I was really looking for a problem on 1V8. Let's switch over to our thermal cam. I think you might guess what spikes up and gets hot right when we plug in our USB-C. Sometimes, not every time, mind you. Okay. Oh, let's switch over to desktop. Okay. What a truth. We plug in USB-C. And it's not doing it that time. This is my insanity. It's like I saw it do it once and then it didn't do it again. Now I'm gonna look like a real asshole. My honor. This fucker got a little bit hot. That 0.3 amp spike. Just like that. Boom. We see this kind of hot pulse go through it. None of the lines outwardly on this chip are, you know, short, kind of just measured, you know, caps, usual suspects. Any of our kind of, you know, voltage amount underscore NAND 0 lines. None of these are short. It's probably just some low voltage rail in here or something like that. Or maybe like an active short. I did try, again, I just put some flux and redid the solder on the chip and no joy. So I'm thinking this has some problem internally. We did part search for this, and we can see it is only on 14 and 16 inch, you know, Pro, M1, M2, etc. At least for ones we have schematics for. I have a bunch of M2 Air donor boards and M1 Pro 13 inch donor boards, but no 14, 16 inch actually. So I went ahead and ordered a 16 inch A2485 donor board. It'll hopefully get here pretty quick. And we will pull that chip off of our Donair and reball it and put it on here. And hopefully this MacBook will work and I can stop and then I never see this MacBook again. Because now it has consumed many hours of my life. But we will see. Frankly, the picture I got of the liquid damage from the shop on intake and really what I saw here just didn't look bad. It was kind of minor just in this area on these caps, and this line wasn't short. You know, I thought, okay, red herring. You know, it probably would have been more reasonable to just assume that, you know, something over here is not good if we're getting corrosion right here. What is kind of weird about it though is, like, at this point now there's like flux and stuff here, but you can, you know, look back at the beginning of the video. It was really only corrosion like right here on these two caps, which were quite corroded, but neither of them were, or the one that was still on the board was, you know, not short circuiting. Yeah, we removed these anyway because they don't look too good. We're going to swap them out later, but once we get this chip, we'll take this guy off and see what happens. In fact, I'm just going to remove this chip from the board now, and we'll look at the underside of it because maybe we'll see some corrosion, something like that under there. I'm going to put a coin, just something to soak up some heat over the NAND ICs here. We'll use a dime. And we just want this so we don't overheat the NANDs. Okay, so I got hot air at 430 C, maximum airflow. And there's already some kind of flux over here, so I don't really need to add more. I'll kind of have this stuff on my table. I need a larger workbench. I need a 30-inch workbench from Global Industrial. Tweezers. Not gonna lie, nothing really out of the ordinary here. I think I did just flick off a little cap. This guy. I'll just try to reball this really quick and see what happens. Did already order a donor, but could use that anyway. bad looking cap I removed earlier. .7 UF, 6.3 volt. Those are the same values as these guys. These are 10 UF, 10 UF. Okay. Oh, we'll get those. Oh, I'm not forgetting to switch back. I'm just gonna reball this chip and put it back on and see what happens. It's still not working, and the little thermal pulse just really makes me think there's something wrong with it. Okay, let's get some flux on this. Back over to microscope vision. This should be a $5 chip that I can just buy off of DigiKey, but Apple says no. Don't sell the chip to anyone in the US, or we won't work with you. So I can't buy the chip as cheaply or as easily as I should, which is really annoying. And right to repair legislation fix all that. So if you're in a state with a right to repair bill being passed and you would like to actually own your stuff, reach out to your local government officials. Now, we'll do this. Still need to fix MacBook, and Apple sure won't do it. First, the A7 iPhone CPU. Fits all. My technician just grabbed a USB-C and is plugging it into something. We can see, oh, it looks like he has a MacBook that's turning on. Very nice. Heard it start up chime. I'm doubtful that a reball is going to help in this case because really the chip didn't look messy underneath. Probably just has an internal issue. Or this chip just is weird and does what it's doing, and I'm totally wasting my time. Well, no. Soon. Really not soon. Well, if it works now, then I guess reballing it was all I needed to do. And if it doesn't work, then, well, I'll do this again with a new chip or another chip from a, not new. None of these chips are new. I can't buy them. Apple says no. But, if this isn't working, then we're just going to try, a chip from another board, basically. Okay. Oops, so balls look around, clean off this chip. wick, the area we're putting it. Doesn't work, I won't be sad. Because I'm kind of not expecting it to. That'd be nice if it worked, though. Then I can make a mental note that a device doing the thing that this one is doing probably has this chip being a bad boy. Supplemental hot air here. We're soaking up a lot of heat. New piece of wick. Take off the backplate on this really quick. Yeah. Good job. Oh yeah, no worries. I just kind of want to have a look at that board and call that person before it gets late or too late. Or ground pads. Just a bigger iron. Okay. Looks good enough. Gotcha. And one is going to be in our lower right. Put some more flux on there. Yeah, man. Have a good night. That is on there now. We'll let the board cool down, and then we'll see what this does. I assume it's going to do the exact same thing, but maybe it won't. And, you know, you might as well try. Okay. Well, this is cooled down enough. See what happens. I assume the same thing. Surprise, surprise, we see the exact same behavior. So when I get a donor, I guess I'll do this all over again. We'll reball that chip, put it on here, and see what happens. A bit of a loss otherwise. That's really one thing of note I see. There's someone who knows more than me that could probably more precisely know why this chip is bad. I don't see any lines around it short, but it does pulse when our current pulses. And well, there's not too much information on these boards at the moment, so still a good amount. Time will tell. Okay, so we'll be back whenever we have our donor in. Okay, so we have a donor board now. I want to get the chip from the donor off. Actually, let's just we're gonna have to take it off and reball it anyway. I think I'll just remove the one we are thinking is bad first. Then we'll prep that board, wick the pads. And then we'll get the one off from the donor and reball it. We're next to the NAND, so just keep like a coin or something around. I have a dime here, a penny would be fine. Just something to kind of add some thermal mass to the NAND flash. Okay, we're back. Just had a string of 6 people come in. Sometimes I must be my own receptionist. It is okay. It is my duty. Gosh, that chip came off really nicely. I think I'm just gonna get the stencil on there and just add some leaded solder, just because these balls are pretty good looks as far as they go. Okay, we're back. Already taken the liberty of drying my paste in a paper towel. All right, so I'm just going to go kind of, I'm just going to set all these parts simultaneously, basically. I'm just double checking the schematic to see the orientation of the chip. I definitely need to get a metal tip syringe, this flux tube. I've already melted the little pink plastic one. Okay. All right, our little dot is right there. Okay. Okay, so we're at low airflow, like 60, we're at 430. See that chip swooped in. And our capacitors. I'm going to crank up the airflow a little bit. I'm basically back to max 120. I just really want to make sure all of the balls there are set. Okay, now we're just gonna let this cool down, and then we'll run power through it and see what happens. Basically, okay, we're doing a little bit of ring around the rosy on this board. So I got my donor. I got this chip, the little SSD controller. You know, here, this is my donor board. I got this off, reballed it, got my capacitors replaced. Here's our patient board.
It's basically doing the exact same thing. I don't see the thermal signaling I was seeing before. Bit of a weird one. We had liquid damage over here, so I kind of thought I was maybe overcomplicating this. Like, it's probably just the chip's bad. Doesn't seem to be the case. We did kind of see weird. I removed this charging IC again. Just kind of prep the area. I'm gonna pull this chip off of an A2485 board and reball it and get it on here and see if we get any difference. The chip number in the schematic for this was the same on the M2 Air board, but I'm thinking maybe it just still is a different chip. We basically saw the same RAA 489900 on an M2 13-inch Air board. I'm pulling one off of the same A2485 board. We're gonna reball that and see what happens. Basically, I think it's the same here. Let me actually double. So this is we have a 820-02382. Let's look at the donor I have is for the just M1 Pro. The one I have as a patient is like an M1 Pro Max Ultra Mega chip. Let me see if we do have the same exact chip number. Okay. Enough talk. Time to reball. Okay. Okay, we're just gonna actually thought I already wicked this area. I think I just removed the chip and added some leaded to these pads. I really thought this device was just gonna have like a shorted PP bus. Okay, I think we can be pretty certain it's not either of these two chips that we thought, because this still does the same exact thing. With either of those chips replaced, we got the caps replaced in the liquid damage area, this charging chip now 2 times, and we got one now from an identical board model. A bit of a loss on this. And there was some liquid damage at the top. Assuming there might be something like really slight somewhere, maybe just have like an open line resistor or something like that. I'm really unsure. I have already scoured this. I'm now kind of going full tweaker mode, really trying to see something that I maybe missed before. These areas on these audio drivers do get messed up a lot. They do look fine on this one. That's something. So, little piece of hair or something. Doesn't really matter. All of our USB-C ports do the same thing. I don't think it's any of the USB controllers. Generally, you'd have kind of one of these is not like the other sort of behavior on that. Anything? Not that 1V8S too short. What is going on here? There's some scratching there. Well, and over here, we don't really care about that side because there's no NANDs. I think this is a 512 gig board. It's a little bit strange. Like a max board with lower storage. Oh, well. We did try to just force DFU. See if it was DFU. It's not. So we were kind of getting current draw that was close to it. So we swapped out this little guy. Solid ball there. It goes far to say visual inspection is not giving us anything useful. So I think I'm going to sit here and measure a bunch of things. See if I can get a better idea of where the power's stopping. Because right now, from my understanding, we're basically going from our AON rails to our S2 rails. We don't have any S2 rails, but there's no shorts on them. We're not really seeing pulsing on the lines, which makes me think maybe there isn't a short anywhere. We just have like an open line somewhere. I'm going to try to see how it's 5VS2 is our first on S2 rail. We'll try to see how that's created and see if that helps us. Okay, this device is very, very troll. I'm going to add a voiceover to the last section, as I kept having people come in on phone calls. And it's kind of weird to be sitting here talking to myself during that, so I'll talk to myself after I close over the other video. Our basic issue on this was we had a soft short circuit on PP 1V8_AON, and we had several red herrings on the device, which was like weird flux residue around our ISL charging chip adjacent component here. And these SSD regulators, we were seeing stuff like we're getting a VN and then no outputs on this chip. Like, okay, maybe the chip. No. We had liquid damage over here, which apparently didn't matter at all. And these two capacitors were no bueno. So those are replaced. This is replaced. This chip is probably fine. This chip is probably fine. This chip was probably fine. They're all replaced anyway. Our main issue was this little thing right here, which is a MOSFET that looks like it talks to the PMU and tells our charger to turn on, basically. So this had an internal short circuit and was bringing down our 1V8 line, but apparently not our 3V3 or 3V8. So we were getting this at 1.2 volts. Basically, we should be getting 1.8. We had 60 ohms in it when we should be getting like 40,000. So as soon as we removed this chip, we saw the resistance climb back up to like 20K ohms or something. Cool. Replaced it. And now we have a working MacBook. You know, when this was brought into from the business, they did ask me to kind of see if it was, you know, technician damage or customer damage. Really, probably neither. I think this is just a random electrical issue. So, you know, bad luck. But that's just kind of, yeah, it's like if you have something on the, you know, in your operating room and it, you know, dies in some way, you're kind of obligated to get it working at a certain point. So that's nice of this business to fix it for this person, because there's just there's no reasonable way to think that they I think they did a top case, and then the customer said he heard like rattling in the case like 3 weeks later, and it was just like a loose screw on the hinge. And then tightening a screw definitely didn't cause this MOSFET to explode, but it works now. This is taking me way too much time. This will probably only be like a 15-minute long video, but I think I've looked at this for like 4 or 5 hours. I kind of was chasing my tail on it a little bit, and then I got sick. So it's probably this made me sick. In any case, it works now, so hopefully I never see it again. I'm gonna put the rest of the shield plates and stuff on and close it up. I hope everyone had a wonderful New Year. I know it's a little bit late, and I haven't made a video for a really long time, but well, I'm honestly still too busy to make a video. But I thought I'd make a video on this one because it seemed like probably this will help someone. This is a pretty weird problem. You know, if you're getting 5 volts, 0.03 amps on all of your ports, you have 1.2 volts on PP1V8 AON, and you basically have all your other AON rails stable, and you have no S2 rails, you might have a bad SLG 4AP43601 STQFN MOSFET. That's what I always say. Until next time, I hope this helps someone. Have a good day.